Hey everyone, I'm back for another video. Hope everyone's doing well. Uh, and I hope you're gearing up for the weekend. I hope that last video was a good video to have. I thought that it's a nice change of pace. It's not all about math at J2 tutoring, so I think it's important to recognize that and that I am here to support everybody in any way that I can, whether it just be, mental, support as well when it comes to rigorous stuff that we're talking about. I may have a video in the future about just study habits and, how to keep your life balanced as well, not just about, the math itself. But today will be strictly a math video. Uh, for all you math lovers out there. And yeah, here we go. So last time where we left off was pre-calc. Doing some pre-calc with horizontal asymptotes, vertical asymptotes, holes, really being able to draw any rational function, starting at the basis of a parent function sometimes, and sometimes you don't even need the parent function, you just go for it, right? And we saw that a lot of the characteristics that we had were seen in the Desmos, and it worked out pretty well. Part that I left out though was an OBA, which is an oblique asymptote, or an EBA, end behavior asymptote. This happens when, and I'm not going to do the whole thing, I'm just going to go over one particular technique that you need in order to solve for this. But this happens when you're looking for that horizontal asymptote and essentially what you're doing. And I'm going to do a video on limits after this one. But just so that you know, essentially what you're doing is like if you have something like this, and this is the winner, remember I said it's a war. If this wins, then you go to infinity, which you're not converging to a certain point. It's not a ratio because the highest degree is here. So you have to figure out what is the behavior, right? It can't just go to infinity, right? Well, it does, but you have to figure out how it does that. So you have to figure out what your asymptote is. And what happens is it's not a horizontal line, right? It's a linear function, or however the function could be, depending on how the division goes. So I'll show you how to divide polynomials. Is essentially what we're doing today. I'm not going to go over synthetic division. It's another technique. That could be a separate video. It's pretty cool. But yeah, we're going to go over long division first because I want you to understand how it works. So let's take this for an example. We're gonna actually let me make it a little bit better. Let's do. And let me also just make a point of this. These might not go in evenly, I'm just saying. I'm just making them up as I go. But I'm just gonna make an interesting point here. If you do something like this. So the first thing you should notice when you're doing something like this is that when you're dividing, whatever the subtraction of the highest degree is of each of the polynomials is what your end highest degree should be. So in this case, we should end up with a line because a quadratic times a line will give us a cubic. So if your answer is not a line, if it's not mx plus b, where the highest degree is 1, then you messed up somewhere. So that's a good check to have. You could also multiply it back across and FOIL it out to get back to this. But here we go. I'm just going to explain how to do this. Really, it's the same thing as normal division. It just gets a little tricky because everyone gets confused with the x's. But let's think about it. So you want to get rid of this x cubed. That's where you're starting. So how are you going to do that? What are you going to multiply this by to get to that x cubed? Well, x, right? That's all you really need. And you're subtracting every term. So you're not going to put negative x here. Okay, what you're going to do is you're going to say, okay, negative, and then you're like, all right, what am I left with? Well, x times x squared is x cubed. X times negative x is negative x squared. And then negative 1 times x is negative x. So, and the reason why I put the negative here is because some people forget to put the negative, and then you start adding by accident. So just make sure you put the negative in the parentheses. That way you don't forget. And then you just move through like you normally would with normal division. So like this is here, this is 0. 2x squared, remember to distribute negative times that. That's 3x squared. And then minus x minus the negative x, that works out. You actually get 0. Right? So now you're left with 3x squared. And you're gonna bring the 1 down, right? You always bring the next number down, okay? And you're like, all right, 3x squared plus 1. What am I really going to do with that, right? Because this is gone. Well, you think, okay, well, what times this would equal that? Well, you got to put the coefficient here. So you're thinking, all right, well, plus 3. Right? And you're just going to multiply through like normal. It's maybe a shorter video today, but that's not always a bad thing. right? So now you're here and you're like, okay, well, this is going to drop out. You're at 3x is by itself because remember, like terms can only go together. And then you're at 4. So here's the good news. Okay, here's the good news. You have a line. Okay, that's the good news. Your remainder is also a line. I don't know if that should have happened. Hold on. See if I can figure out why. Okay, yeah. So looking at this is exactly where we're supposed to be. I I thought back for a second. I wanted to make sure I was right, but no, this is right. So, and here's how you check, right? You think, okay, well, my quotient is a line. That's good, right? That's what we said we needed it to be. And then the remainder is a line too, but we'll see why that is. So when I multiply this out, we're going to try it. And how you would write this essentially is you would write, okay, well, my answer is x plus 3 plus 3x plus 4 over x squared minus x minus 1. Right? So now you're here. You're like, okay, well, let's check that and make sure we get the right thing. So first we're going to multiply by x plus 3 and see what we get before we deal with the remainder. When you do this multiplication, you're essentially going to have x cubed minus x plus x squared minus wait, no, this is supposed to be x plus 3. Sorry. Plus x plus 3x squared minus x squared. So that's plus 2x squared. And then you say, all right, well, you know, minus 3x minus x minus 4x and then minus 3. Now, why is this good? Well, because if I were to multiply this by that, you add 3x and you add 4 and you end up with your ending here. So this is essentially how you divide polynomials. Now, why is this important for asymptotes? Right? Why do we care? Well, typically when you're doing an asymptote, you're gonna end with it's gonna go in evenly. So, but besides that, your end factor, whatever this end factor is, when it does go in evenly, when it's worth it, right? This quotient is going to be your asymptote that you get. That's why it matters, because then you draw according to the asymptote, right? And of course, if you have, intercepts you got to deal with, you got to cross it, but then it's got to hug it afterwards, like we did in the last video. That's essentially what this is. So this is a shorter video than usual, granted, because this is all I really wanted to go over today. I just want to go over division. But, sometimes shorter videos are better than longer ones. So, if you have anything that you would want me to go over in future videos, just like put in the comments. I could do basically anything up until calculus. I could even do proofs if you want. I can go over proof techniques. So really anything up until discrete math I can do. I can do differential equations, whatever you guys think. I'm focusing on high school stuff and SAT stuff eventually because I think that's the most important right now, but whatever you guys think. And the next video will probably be either on limits or just what I think is best for study habits and how to do well on exams and just advice. All right? Okay. Have a good night.